So that was 30 with y equals the natural log x and dy. And we determined the integral and we plugged it back in. Now 36 will be a definite, the integral from 0 to pi over 4 from 1 plus tangent t to the third times secant squared t dt. Remember the problem with, potential problem with definite integrals. If the function is not continuous on the given interval, in this case 0 to pi over 4, we will write the fundamental theorem of calculus is not applicable. So this is 1 plus tangent t to the third times secant squared. Well, tangent is defined on 0 to pi over 4. Secant is defined on 0 to pi over 4, so the function is continuous as a product of continuous functions. So next step is, very good. So let u this time 1 plus tangent t, only if du is in the problem or easily makeable, meaning just a constant, a factor, can be adjusted. So what do we get? Yes, secant squared t dt. And here it is. So do not copy the limits of integration, please. So what is the integral now? U to the third du. And now, when t is 0, how much is u? 1. When t is pi over 4, how much is u? Tangent pi over 4 is the easiest angle because sine and cosine are the same. The same.
You said sine?
Sine and cosine are the same for pi over 4. Yes, but if they are the same, tangent must be 1. Tangent is sine over cosine, right? So 1 plus 1 is 2.
Oh, 1 plus 1.
So this will be u to the 4 over 4 from 1 to 2. Leave 1/4 outside, plug in 2, you get 16 minus 1, so 15 over 4. Never involve the constants. They can wait patiently outside till you perform the calculations and then you multiply. Questions? Problem 20. Any questions here?
Can I just do it?
Please.
Can
Go.
I just do it like the first one and then put the numbers at the end?
Depending on which numbers you're going to plug in.
I'm confused.
So when you move from t to u, you cannot write the same limits of integration. If you do write the same limits of integration, it's incorrect. So because it's a definite integral, when we change from the integral from t to u, we have to determine new limits integration for a variable that is u. These are the limits of integration for variable t. These are corresponding limits of integration for variable u. There is no point in going back. This is a definite integral. The answer is a number. Why would you go back and then there is no point? Can you do it? Yes. Is it acceptable? Absolutely. Will you get the same answer? Right.
So
But if you copy 0 to pi over 4, that will be incorrect.
so you plug in the number into u.
So u is a function that is 1 plus tangent t. If t is 0, I get 1. If t is pi over 4, I get 2. That's the easiest thing to do and move forward with that. It's up to you. I accept both methods. But I don't want to look backwards for no reason. because I cannot write the integral with any limits. Okay, 20. The integral from -1 to 1 from sine x over 1 plus x squared dx. First, we check whether this function is continuous on the interval -1, 1. That's our first thought. And the answer is yes. This function is continuous everywhere. 1 plus x squared is never, ever 0. So that's fine. So what do I do next then?
It's part of our solution to need us to say that.
It's part of the solution to check. Yes. Yes. You don't have to write it, but if you very good question. So let me explain why. So the integral from 0 to 4 from 1 over x minus 2 dx. This function is not continuous on 0, 4. Fundamental theorem of calculus is not applicable. And you're done. That's why every time I see a definite integral, I will check or think whether, or check whether the function is defined on 0, 4. Now, when I see a definite integral and a symmetric interval, in addition to verifying that this is continuous, I know there are two possibilities: for the function to be odd or for the function to be even. So every time I see a definite integral, I check whether the function is continuous. Second thing is, if I see a definite integral with a symmetric interval, I will always try to identify whether the function is odd or even. What if it's odd? What if I show that it's odd? What is the answer? Zero. What if it's even? What is the answer? I can change it into twice the integral from 0 to 1, which is easier to calculate. Do I have to change it? No, you don't have to. But it's easier to calculate an integral from 0 to a number than from -1 to 1. Okay, so what can you say about this function? Obviously, it's continuous. So the fundamental theorem of calculus is applicable here. Part 2, of course. But is it odd or even or none of the above? It is odd. Everything that has sine, not sine squared, or sine to the fourth, everything that has sine in it potentially can be odd. Because when I replace x by -x, this does not change. But when I replace x in here, I get negative sine x. The whole thing is odd. Yes, and the answer is 0. And I'm done. So please keep that in mind. Any questions? Any questions? Today is November the 18th. Okay. We continue with integrals. Is that a yes? More integrals? Okay. What about 35? The integral from secant theta tangent theta over 1 plus secant theta d theta. Let's think about this for 1 minute. we have any suggestions on this? Yes?
That you could be 1 plus
Excellent. Yes, indeed. Let y be 1 plus secant theta. dy equals secant tangent d theta. Is dy in the problem? This is an indefinite integral. We are looking for a function, the most general antiderivative. So this is the integral from, can anyone dictate? Okay, dy what? Dy over y. Excellent. Good. So what is this? What is it? Which function prime is 1 over y? Yes, but it has to have the absolute value. We know that, and we know why. So then this is natural log of the absolute value of 1 plus secant theta plus a constant c. Very good. Okay, so let's look at a property like, let's say 51. On page 418. The integral from 0 to 1 from x squared cosine x. Do not try to evaluate this. You can't just yet. You have to wait till the next class when you study integration by parts. So we cannot even attempt this right now. Okay, so the problem is asking us, let's read the question. It says, use the properties of integrals to verify the inequality. We're not asked to determine the integral. We can't on this one. Good. So where is our starting point? Say it again. No, what do we have to write first? We just have to show that this is true. So we have to start somewhere. In all these examples, where did we start? What was our first thing we wrote? Say it again. Yes, it is continuous. No. So here we're asked to just show this, that this is true. We cannot determine this. Don't even try at this point. We don't know how. We want to show that this is less than or equal to 1/3. So what will we have to write first? Look at all this and say, the only thing I know is what? Just read it. Read the integral and say, oh, one thing I know for sure. What do I know?
Plug in 1.
Not yet. Exactly. Yes, that's all I know. I don't know anything else at this point. That's all I know. That x is a number between 0 and 1, guaranteed. Agreed? Perfect. Okay. So when it comes to cosine, this really means that x is between 0 radians and 1 radian. Okay, now careful. Let's take a look at function cosine. Between 0 and pi over 2, is cosine an increasing function or a decreasing function? Yes, indeed. It's a decreasing function, which means this is a little bit more than 1. So this is 0 and this is 1. On the interval 0 to 1, cosine 0, cosine x, and cosine 1, what is the relationship between them? Or x between 0 and 1. Which one of these two numbers, cosine 0 or cosine 1, is bigger? Right. So then cosine 0 is bigger than cosine, which is bigger than cosine 1. Very good. Excellent. Why? Because cosine is decreasing. Is a decreasing function on the interval 0, 1. I am going to write this inequality from, I don't need this here, sorry. I'm going to write the inequality in the correct order. I'm just going to copy what I see and write it in the correct order. Cosine 1 is less than or equal to cosine x. And how much is cosine 0? 1. Excellent. So remember what the target is. The target is to build this inside. So for now, I have that cosine 1 is less than or equal to cosine x less than or equal to 1. As you see, I may not be interested in both sides, but we'll see in a moment. So I have cosine that is squeezed between cosine 1 radian and 1. I need to multiply by x squared, but I have to be careful with this x squared. So is x squared a number that is positive? Yes. Is this number 0? No, the endpoints of the interval don't count. So I can multiply all three sides by x squared. So x squared cosine 1 less than or equal to x squared cosine x less than or equal to x squared. I multiplied all three sides by x squared because it's not 0 and because it's positive and I don't have to switch the inequality symbols. Okay, it turns out that I really don't care for this piece. And I know that this function is less than or equal to this function. Therefore, there is one property of the definite integral that says what? If a function is under another function, the area under this and the area under this are in a particular relationship. So the integral dx, of course, between 0 and 1. So the left-hand side is, I built on the left-hand side exactly what I wanted. I wanted the integral from 0 to 1 from x squared cosine x dx and less than or equal to, and now this I can determine. Can anyone tell us the antiderivative of x squared? And from 0 to 1, when I plug in 1, I get exactly what I was supposed to get. So without calculating the integral of x squared cosine x dx between 0 and 1, we are able to guarantee that whatever the number is must be less than 1/3. Okay, 54 caught my eye. Would you like to do another property or something else? We want another property or something else? Okay, so 54 caught my eye. So let's see what that is all about. (54) 418. And that is the integral from 0 to 1 from x sine inverse x dx. And they say that it's less than or equal to pi over 4. I have no idea. Maybe. Okay. Again, where is our starting point? Of course, that's what we know. That must be the starting point. Guaranteed. Well, now when we talk about a trig function, we really mean 0 and 1 radian. Okay. Now, for this, because we're talking about sine inverse, we mean 0 and 1. So when I apply, first of all, is sine inverse an increasing function? Yes. Between 0 and 1, or between 0 and pi over 2, yes, it's an increasing function. So is its inverse. So I'm not going to switch the inequality symbols. So I will apply sine inverse to this, sine inverse to this, and sine inverse to this. And I have to get angles now. Which angle has sine 0? 0. Sine inverse x. Which angle has sine 1? Excellent. For now, I have built this piece. Not enough. Because that's not the function I'm interested in. The function I'm interested in is x times blah, blah, blah. So what do you think I am going to do to all three sides at this point? Is x positive?
Yes.
Yes, because it's between 0 and 1, and it's not 0. Okay, perfect. So we're going to multiply everything by x. So as you see, I don't care for this piece. So I have x sine inverse x less than or equal to pi over 2x. I built what I wanted. I found that this function that we are looking at is less than or equal to another function, which is pi over 2x. So knowing that, and knowing the property of inverse the property of definite integrals, then do not forget dx, without which the integral doesn't exist. So the area under the first function, which is lower than the second one, must be lower than the area under the second function. So we cannot determine this, of course. We are not even asked to. But I'm hoping I can determine this. So it's less than or equal to pi over 2. What function prime is x? Over. Good. From 0 to 1. Luckily, I don't have to plug in 0, but when I plug in 1, I get pi over 4. And that's exactly what they were telling us. We don't know what this is, but we know this integral must be less than pi over 4. Less than 1. Good. What should we continue with, please? More integration? More substitution rule? Yes? No? Any questions? Yes? Definite, indefinite? Okay, very good. Um, 73 caught my eye. On page 414 now. The integral from 0 to 1 from dx over 1 plus the square root of x to the 4th. This looks ugly. At least initially. I don't know. Any suggestions? So let u be, yeah, I would prefer this. We'll see in a moment. Let's look at du. I hope the du is in the problem or easily makeable. So what is du? Yes, so it's 1 over 2 the square root of x. That's not enough. Dx. Oops, I do have a 2 the square root of x in there. Not a problem really. How come? So first of all, do not copy the limits of integration. Let's put them in right now. When x is 0, what is the lower limit for u? When x is 1, what is the upper limit for u? 2. Okay, perfect. The denominator, you will say, is definitely u to the 4th. Bless you. So now dx you can write as you cross multiply. So dx is 2 the square root of x du. But I can't have x anymore. I wish I could write in here, instead of dx, 2 the square root of x du. But I can't. This has to go away. But it's not a big deal to solve this one for the square root of x. And now everything changes to u. So I copy the 2. I copy the square root of x as u minus 1 and du as du. Now I will move 2 in front, and I have to separate the fraction into 2 fractions because I can't solve this. So, any questions so far? Any questions? 2. The integral from 1 to 2 from u over u to the 4th minus 1 over u to the 4th du. I'll simplify and I'll simplify. The integral from 1 to 2, u to negative 3 minus u to negative 4 du. 2. Now I'm ready to find the antiderivative. Okay, so which function prime is u to negative 3? And you will have to say u to negative 2 over negative 2 minus, not plus. I rushed to write plus, I don't know why. It will be plus, but I can't write plus just yet. So minus u to negative 3 over negative 3. Increase the power by 1 and we divide by the same number. Sorry about that. That's your 2. So when I plug in 2, I get 2 to negative 2 over negative 2. Minus, when I plug in 2, 2 to negative 3 over negative 3. This is really ugly. Minus, in parentheses, let's put brackets here. Parentheses, when I plug in 1, 1 over negative 2 minus 1 over negative 3. Awful. Okay. So 2. 2 to negative 2 is 1 over 4 times negative 2, negative 1 over 8. This becomes plus. 2 to negative 3 is 1 over 8 times 3, still 24. Plus 1/2. This is minus, plus, but minus in front, minus 1/3. That is ugly. Least common denominator 24, a 3 here, nothing here, a 12 here, and an 8 here. So -3 and +1 and +12 and -8. Ah, that's nice. No, it's not. So this is 13 minus 3 is 10. 10 minus 8 is 2. 2 times 2. So this is 2/12 or 1/6. Let me do this again. 13 minus 3 is 10. 10 minus, because I don't trust myself today, 2. So I simplify by 2 and I get 12. 2 divided by 12, 1/6. Questions, please. Questions? Okay, another definite or indefinite or Riemann sum or anything else? Please choose or I will. Maybe another fundamental theorem of calculus part 1. The limit of the Riemann sum. Antiderivatives. What about this? Problem 5 on page 417. We're told that the integral from 0 to 6 from f of x dx, is it 0 to -6 or 6? 6. F of x dx is 10, they say. The integral from 0 to 4 from f of x dx is 7. They want us to find the integral from 4 to 6 from f of x dx. What is it? How much? Very good. Excellent. What about 24? Same page. The integral from 1 to 10 from x over x squared minus 4 dx. Any suggestions? Any ideas? Let y be? Okay, let's give it a shot. As long as dy is in the problem or close. Excellent. Not a problem. I'm missing a 2. I don't care about it. Not a big deal. 1/2 in front. Do not copy the limits of integration, please. So please tell me, what will you copy? Good. Till what? Very good. From what? Excellent. And I fell into my own trap. And I fell into my own trap. I keep saying we have to check whether it's continuous, and I didn't do it. And that's what happens. No, I did not try to trick you or anything. I just went ahead because I liked this integral, the way it looked, but I did not check. Is this function continuous on 1 to 10? No. So FTC, not applicable. I just liked the way it looked, but I wasn't thinking. And here's when I realized that something was wrong, because you would have said, next step, dy over y. But then when I put the y in there, natural log of y, then I do have the absolute value, but still, dy over y is not continuous between -3 and 96 because y is not defined at 0. So the whole thing collapses anyway, eventually, if I don't notice this, but we should always check from the beginning. My apologies, I should have said that. So of course there is no need for all this. Good. Let's look at 22. The integral from 0 to 1, e to the x. These are improper integrals, and you will study them in Calc 2. Good. Is this function defined between 0 and 1? Yes, it is everywhere. There is e to 2x is always positive, plus 1 is always positive. The denominator is never 0. E to the x is always defined. No questions. Everything is okay here. So then, any suggestions? What will you say? Let u be. I will be in trouble with that. Yes, if I use just e to the x, then du will be excellent. And let's see what we get. Do not copy the limits of integration. Think. When x goes from 0 to 1, then u goes from 1 to excellent. So now let's see what we have. Please change the function and tell me what to write. Yes, the numerator is indeed du. And what about the denominator? Very good. And we know what this is. We've talked about it so many times. What is it? Which function prime is this? Very good. From 1 to e. So this is arc tangent e, which no one can determine as an angle, but minus arc tangent 1, which angle has tangent 1. We talked about it today. That's it. And you don't have to go back. Okay, 33. the integral from x to the third over 1 plus x to the fourth dx. Okay, any ideas? You can use any letter. You don't have to use Y, you don't have to use U. You can use A, B, you can use any letter you want, as long as, excellent, as long as dy is easily makeable or in the problem already. What do I write? 4x cubed. Very good. Not a problem whatsoever. So then this is 1/4, and the integral becomes what do I write? Exactly. Which is 1/4 natural log of the absolute value of y plus a constant c. It's an indefinite integral. I have to get a family of functions or the most general antiderivative. I have no choice now. I have to go back and replace y. So this is 1/4 natural log, the absolute value of 1 plus x to the fourth plus c. But 1 plus x to the fourth will always be a positive number. I can, at this point, drop the absolute value. Only because 1 plus x to the fourth is always positive. Otherwise, I could have not dropped the absolute value. I know we have 5 minutes left. What would you like to do in 5 minutes? You cannot say a limit of the Riemann sum because you will take more than 5. In the next course, you will talk about volumes and areas of rotation. You will talk about techniques of integration and improper integrals when the function is not continuous or the limits, both or one of them, is infinity. Direction fields, conic sections, and series. That will be the next course. Another, I think, 6 chapters. Maybe it's 6, 7, 8, 9, and 10. 4 chapters. 6, 7, 8, 9, and 10. 5. Okay. What would you like to look at? Say it again.
So I was going to say, how about weather sine 5, 5, number 26?
Yes, yes. I just need to see it. What you tell me what it is? Yes. So the integral from 0 to 2. 1 over 8 dx. So, the integral from 0 to 1/8 from sine inverse 4x. Yes. Sorry about that. So the integral of 0 to 1 over 8 from sine inverse of 4x divided by the square root of 1 minus, is it 16x squared dx?
Yes.
So sine inverse 4x, yes, you can take it. It's fine. I got it. Okay, very good. Awesome example. Thank you. Good, so let's take a look. Let y be. So let's give it a shot. I like Ella's idea. Sine inverse of 4x. Let's see what happens. There is more than one correct, but sometimes there is more than one correct substitution. Good. So this is a very good idea. So as long as dy is in the problem or easily makeable, can anyone give us the derivative, the differential first the derivative and then times dx, but the differential of y.
Yeah.
Yes, 1 over the square root of 1 minus (16) x squared, very good, of course, times the inner function prime, which is 4, times, no problem, easily makeable. So 4 dx and the denominator, all these make up what? This is dy. Copy 1/4, do not copy the limits of integration. So please tell me what is the lower limit. Sine inverse of 0. 0. Sine inverse of 1/2, because it's 4 times 1 over 8, which is 1/2. Which angle has sine 1/2? The other one, the small one, pi over 6. Good, so let's see what's left. If this is dy, what is that? Y dy. It couldn't be easier. It was a perfect example. Perfect idea. So this is 1/4 y squared over 2 from 0 to pi over 6. Do not involve the constant. Make it wait. Plug in pi over 6. Plug in 0. I don't have to write anything. So this is pi squared over 288. Perfect example, Felix. Thank you.